they're kind of the hidden workhorses of the mechanical world. I mean, they're in everything from your bicycle to a massive container crane. They're moving assembly lines, lifting these incredible loads, and it's all thanks to a pretty simple interlocking design. So today, let's explore the powerful and, surprisingly elegant world of chain drives.
So think about this for a second. When you're on a bike and you push down on those pedals, have you ever really stopped to think about what's actually getting that power to the back wheel? It's this simple little mechanism that, believe it or not, quietly revolutionized the way we move.
And at its core, it's just a beautifully simple system, right? You've got a chain, which is just a series of these interconnected links, and then you've got sprockets, which are really just wheels with teeth. As one sprocket turns, its teeth grab the chain, pull it along, and just like that, you're transmitting mechanical power with, perfect precision. And here's the secret weapon, the real reason this matters. See, unlike a rubber bolt which can stretch and slip when you put it under pressure, a chain drive creates this positive physical lock. The teeth and the links engage directly. There's absolutely no slip. And that means pretty much all the power you put in on one end comes out the other. It's just incredibly efficient.
Okay, but this whole no-slip idea isn't some one-size-fits-all solution. Nope, it's been adapted and tweaked for a huge range of jobs, and they pretty much fall into three main families.
All right, so first up, you've got your hoisting and hauling chains. These are all about pure brute strength. Just picture those massive chains lifting shipping containers at a port. Then you've got conveyor chains. These are really the backbone of manufacturing, right? They're designed to just smoothly move materials down an assembly line. And finally, we have the ones we're probably most familiar with, power transmission chains. These are the guys responsible for getting power from an engine to the wheel on a motorcycle, or of course, your bicycle.
So let's zoom in on those heavy lifting chains for a sec, because the engineering is pretty cool. The basic design, it's just a simple oval link. But for the really, really extreme loads, engineers added this tiny piece of metal, a stud, right there in the middle. And this one brilliant, super simple addition dramatically increases the chain's strength. It stops the links from bending or warping under all that tension. I mean, it's just a perfect example of elegant problem solving.
Okay, so now let's shift gears and zoom in on the application that really brought the chain drive into our daily lives, power transmission.
It's hard to overstate this. The chain drive completely revolutionized personal transport. I mean, before 1885, bikes were these clunky, awkward, super inefficient machines. But then the safety bicycle came along and it changed everything. See, by using a chain drive, it suddenly allowed for two equal-sized wheels and a much, much more efficient way to get power from the pedals to the back wheel. It made cycling safer, faster, and suddenly it was accessible to just about everyone.
But of course, there was a catch. These early chains had a major problem. All that simple metal-on-metal contact, it created a ton of friction. They were loud, they were grindy, and they wore out incredibly fast, especially as people wanted to go at higher speeds. And the solution was, well, it was totally ingenious. Instead of just letting the chain's links slide and grind against the sprocket teeth, engineers added these small, freely spinning rollers. And just like that, you transform that high-friction sliding motion into a much smoother, almost effortless rolling motion. It's a brilliant little fix.
And honestly, that one single change, just adding those little rollers, was a complete game changer. It's what created the modern roller chain that we all know today. It turned this clunky, noisy mechanism into something smooth, quiet, and durable enough to handle high-speed engines.
So how efficient are we talking? Well, get this. A modern, well-maintained motorcycle chain drive loses only 1 to 4% of its power getting from the engine to the wheel. Just think about that. That is an astonishingly small loss of energy. Almost everything you put in, you get out.
But you know how it is? Like everything in engineering, there's no silver bullet. It's not the perfect solution for every single problem. For all of its amazing strengths, the chain drive definitely comes with its own set of trade-offs. So on the one hand, the advantages are super clear, right? You get incredible efficiency, zero slipping, all in a compact design that can handle really harsh conditions. But on the other hand, that top-tier performance requires care. Chains need constant lubrication. And that rigid, no-slip connection, well, sometimes that can actually be a drawback, especially when a system needs a little bit of give to prevent damage.
So yeah, that high performance definitely comes with some responsibility. If you want to get that long life and keep that amazing efficiency, the routine is simple, but it's absolutely essential. You got to keep it clean from all that abrasive grime, you got to keep it lubricated to fight off wear and tear, and you need to keep it protected from the elements.
So with all those trade-offs we just talked about, you have to ask, why is this centuries-old mechanical system still so fundamental to modern engineering? Why is it still around?
Well, it really just comes down to this. Its core principle is just that good. When a job demands reliable, super efficient power transmission with absolutely zero slip, the chain drive is still so often the best tool for the job. That blend of raw strength and pure mechanical precision, it's just incredibly hard to beat.
And all that leaves us with a really fascinating question to think about. I mean, in a future of silent, direct drive electric motors and all these advanced composite materials, what's the next evolution for this mechanical marvel? Where is the simple, enduring power of the chain drive going to pop up next?